question 1. So arithmetic sequence, the first term is 3 and the second term is 7. So if we're trying to find the common difference, it's going to be 7 take away 3, which is 4. Find the 10th term. So we're going to use the formula booklet. Oops. Let me just snip this here. I'll just snip this whole thing just in case we need one of these. Okay, so if we're trying to find the 10th term of an arithmetic sequence, we're looking at this formula here. So we know that U10 is going to be U1, which is 3 plus 10 minus 1 times 4. Multiplied by 4, I should say. 3 plus 9 multiplied by 4. Which is 39. Find the sum of the first 10 terms of the sequence. Now, because we do actually know the 10th term, we could use this formula here. So you've got an option, or if you're more comfortable, you can use this one. I'll do both just so you can see what the situation is. But as I say, you can only use this one because we're trying to find the sum of the first 10 terms, and we did already find U10. So let's go with that one first. So that would be, okay, so S10 is 10 over 2 brackets 3 plus 39. So that's 5 multiplied by 42, which is 210. If you struggled with that, obviously you can do this. 5 times multiplied by 2 is 10, 4 multiplied by 5 is 20, plus the 1 is 21. If we use the other formula, it would be 10 over 2, so now I'm talking about this one. Brackets 2 lots 3 plus 9. I did that in my head, it's alright. 4, 5. Oops, sorry, that's 6. Can't be mind writing. 9 multiplied by 4 is 36. 5 multiplied by 42 is still 210. Okay, that's question 1. Alright, so question 2. We're trying to find the inverse of the function f(x). So we write y equals 5x, we switch our x and y, and we rearrange to make the y the subject. So f minus 1 of x is x over 5. Find FOG7. Okay, so you've got a couple of ways you can do this. You can find FOGX and then substitute 7. But when they do have a substitution of a value, it's always easier to actually just find those numbers and substitute them in. So to do FOG7, we would be finding G7 first. That value is then going to be substituted to F. So G7 would be 7 squared plus 1. 7 squared is 49 plus 1 is 50. And we're then substituting that into fx. So f of 50 is 5 multiplied by 50, which is 250. Okay, so we've got the 4th row Pascal's triangle. So the 5th row, you're just adding the terms up above it. So 1, 5, 10, 10, 5, 1, if you want to rewrite that neatly. And then the hence or otherwise find the term in x cubed. Okay, so this is where we're using this here. Okay, so we're very familiar with this. So in our case, our n is 5, and we're trying to find r. We've got 2x. Remember, that has to be in brackets. I can't stress that enough. Lots of you are still forgetting the brackets. 5, take away r. Oh. And then my b is 3 to the power r. You've got to remember, girls, that this is all being multiplied together. Okay, so there is no addition signs in here. The addition signs from the formula come in between each term. Okay, but the individual terms themselves are just, they're all multiplied by each other. Alright, so if we're trying to find the term with x cubed, there's only one expression here that has x in it, so we know that this power up here has to be 3. So we know that 5 subtract r has to be 3, so r has to be 2. So we are then finding 5, 2, 2x all cubed, 3 to the power 2. Right, we had to find the 5th row of Pascal's triangle. Remember, when we are counting, we start with 0, 1, 2, 3, 4, 5. And so if we're finding 5, 2, we are identifying this is our value here. So that's 10. 2x all cubed is 8x cubed. And then this is 9. So then we've got 10 multiplied by 8 multiplied by 9, which, x cubed I should keep, which is 720.